Moving on, we are now going to look at how our knowledge so far of binary systems and bitwise operators opens up a whole world of new opportunities in solving interesting problems. So let's use our knowledge so far. Let's develop an application where a user can give us a color, and using our system they should be able to generate a darker shade of the color, a lighter shade of the color, a cooler version of the color, or a warmer version of the color, or they should be able to invert the color into an opposite color. So before we begin developing the system, let's understand how the colors actually work. For any color, there are essentially three channels. There's a red channel, green, and blue channel. It's the combination of these three channels that creates typically any color. The value any of these channels can hold at any given point is between 0 and 255, which is 0 to 255 for the red, 0 to 255 for green, and the same for blue. And if you think about it, this can hold 1 byte, and similarly 1 byte for green and 1 byte for blue, which means 8 bits each. That is which basically means they can hold values which means they can hold the values from 0 to 255, 8 bits each. You would typically represent the color codes in either decimal format or a hexadecimal format. Decimal format is base 10, hexadecimal is base 16, RGB say 255. That is equivalent of RGB 255, 255, 255 for red, green, blue in decimal, or the equivalent for the white color in hexadecimal. We've seen an example of conversion in the first video, so please refer to the first video. But essentially in hexadecimal you can use the digits between 0 to 15, just like in base 10 you can use the digits between 0 to 9. So essentially it's 0 to 9 plus 10 is represented by A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. So similar to the base 10 decimal system, you normally use the 0 to 9, and 10 in hexadecimal is represented by A, 11 by B, 12 by C, 13 by D, 14 by E, and 15 by F. So now if you look at this, it's 15, 15, 15, 15, 15, and 15 into 16 power 0 into 16 power 1 into 16 by 16 power 2 by 16 power 3, and so on. And you'll essentially end up at the same values. And this is your red for green and blue. Now let's use this knowledge in developing that system. Now what we have here is empty HTML template for the application that we are going to develop. If you look at the body, we've just got a heading, a label with an input for the user to enter the binary for the red color, the same for the green color, and the same again for the blue color. Then we have a button to apply the color, and then we have a box that will show the color back to the user. And then we have the script to implement the apply color function. We can look at the live preview of how this application looks so far. So this is how the application looks at the moment. So what we want to do is when the user enters the binary values for all the three channels and clicks on apply color, we want to show that the color that they have applied. So here, first we are going to read all the three channels from the user's input, convert them to a decimal format, then format that into the color, and apply the color to the box. Let's say we have default black color, then once the user clicks on the apply color, it will generate the black box. If the user is setting only the red channel, you'll see it's only red. Let's say the user also set green channel, you'll see it becomes yellow. And if they set blue channel, it'll be a shade of gray. So this is how the user can enter different 8-bit values for all the 3 channels and generate a color. Now let's say the user wants to generate a darker version of that color. So we'll add the button apply darker shade. Essentially we're going to read all the 3 red, green and blue channel values that the user has provided and shift the color 1 bit to the left. We now have this helper function as well. What this function does is it updates the input fields with the newly generated color and also applies the color to the box. So let's see how this works. Let's say the user has given default values. So we have a red there. Let's see how the darker shade looks. As you can see, the bits are shifting to the left by 1. We can do something similar to apply the lighter shade. We've added the lighter shade button. We've implemented it here. We'll read the 3 channel values, and this time we are going to shift the values 1 bit to the left. We need to make sure that the maximum value cannot exceed more than 255. So we set an upper limit and we choose whichever is the minimum value between the two. So let's see how this works. So we apply the color. We want a lighter shade. So as you can see, the bits are shifting to the left. And the color is, so you can apply darker shade or lighter shade. Let's say the user wants cooler versions of this color. So we are going to add the button for cooler color and apply that here. So for the cooler colors, usually the reds are low and blues are high. You would keep reducing the reds and increasing the blues. So let's see how this works. Apply cooler color. You can see the blue is increasing. And if you want like a lighter shade, or a darker shade, let's do the same for generating the warmer colors. So we add a button to apply the warmer color, and then we'll implement that. For warmer color, the reds go higher and the blues go lower. So let's see if you apply the black, so now let's say the user has given a color and they want the opposite color. Another button again and call it apply invert color. So let's implement this. So the apply invert color essentially apply an exclusive OR against the maximum value, which is 255. So essentially it just inverts all the bits. So you will see once you apply, all the bits become 1 and the color is white. And then if you invert again, it's black. If you want a lighter shade or a cooler version, and then if you invert, you'll see the bits are essentially flipping to the opposite